Hello everyone and welcome back. My name is Mr. Kovalt, and in this video we're going to go over how to figure out what the fraction is of a certain substance that dissociates at equilibrium. So let's get into this. Okay, so here's the question. The equilibrium reaction N2O4 in equilibrium with 2 NO2 gas has been thoroughly studied. If the total process in a flask contains, if the total pressure in a flask containing NO2 and N2O4 gas at 25 degrees Celsius is 1.50 atmospheres, and the value of the Kp at this temperature is 0.148, what fraction of N2O4 has dissociated to NO2? Okay, so where do we begin? Well, the first thing we want to do is write out what information we're given. So we're told that the total amount of pressure for the system at equilibrium is 1.5. And so you can see here that this system here, this reaction only has two gases. So that means that the total pressure, right, is equal to 1.50 atmospheres, which is going to be equal to the partial pressure of N2O4 plus the partial pressure of NO2 at equilibrium. Okay, so then we can solve this equation for one of these. So we have this relationship here, right? And then we can solve, and then we can have K, we need our K expression, our expression for the equilibrium constant for this reaction. So if we write that out, we have Kp is equal to, and it's going to be the pressure of the products over the pressure of reactants raised to their stoichiometric coefficients. So here we have a 2 coefficient. So here we're going to have the pressure, the partial pressure of NO2 squared over the partial pressure of N2O4 raised to the 1 power, so we don't need to write the 1. And then if we solve this for NO, then we could substitute that for this into this equation here. So if I rearrange this, so if I subtract the pressure, the partial pressure of N2O4 to both sides, then I get the partial pressure of NO2 is equal to 1.50 atmospheres minus the partial pressure of N2O4. So now, notice I have the partial pressure of NO2 squared in this formula, in this equation, and then I solved for the partial pressure of NO2. Now I can substitute this in for this. Okay, so now I can go ahead and put in this. So 1.50 atmospheres minus the partial pressure of N2O4, and that's going to be squared all over the partial pressure of N2O4. So now this is going to be equal to the Kp, and the Kp we said was 0.148. So let's go ahead and put that 0.148. So now what we can do is solve this and write a quadratic formula, get this into the form of a quadratic equation. So if we multiply both sides by P N2O4 and then multiply this by P N2O4, and then we can unfoil this as well. right? So then we have 1.50 minus the partial pressure of N2O4 squared is going to be equal to 0.148 times the partial pressure of N2O4. So now we can unfoil this, and when we unfoil it, we get, excuse me, 2.20. Let me see for a moment here. 2.20. So we're going to have 2.20. Oh, I'm sorry, 2.25. And minus 3. So we're going to have minus 3p N2O4. And then we're going to have plus p N2O4, and this is going to be squared, and that's going to be equal to 0.148 times the partial pressure of N2O4. So now I've unfoiled this, and I got this. This is equal to this on this side. And now I can bring this over here, so I can subtract both sides. So I can bring this over and then have my quadratic equation equal to 0. And when I do that, I get, let's see if I can write this straight, 0. Hold on a second. Let me double check. Yeah. So I'm going to have 0 on this side, and then I'm going to have 2.25, so 2.25 minus 3.148, 3.148 partial pressure of N2O4 plus the partial pressure of N2O4 squared. So then I have this quadratic formula. Let me just double check to make sure I didn't write it down incorrectly. Okay, now, excuse me. So since this is my quadratic formula, or my quadratic equation, I'm now going to have to use the quadratic formula to solve it. So let's go ahead and do that. Okay, here we go. So here's the quadratic formula. Instead of x, I have the partial pressure of N2O4, because instead of x, we have that we have the partial pressure of N2O4 in our quadratic equation here. So here I have this is equal to the quadratic formula, and so just as a reminder, the coefficient here is 1. So let's fix that. So we have 1 here, and that's going to be A, and then this coefficient here is B, and then there is C. So we just plug that in, and so we're going to get P, the partial pressure of N2O4, is equal to negative B, which is already negative, so it's going to be a negative times a negative 3.148 plus or minus the square root of B squared. Again, B is going to be negative 3.148 squared minus 4 times A, which is 1, times C, which is 2.25, and then all of this is over 2a, and again, a is 1. And so now we have everything plugged into our quadratic formula, and then we just solve and find our two values. We're going to get two values because it's plus or minus, and then we'll pick the one that makes sense. So when we calculate this out, you should get the partial pressure of N2O4 is equal to 1.574, 1.574, or what's the other one? 0. Oops. I forgot a step. So it's going to be 1.574 plus or minus. This is where, so we figured this out. And then it's going to be plus or minus 0.47, 0.4769. And then I'm gonna add this to this number, or I'm gonna subtract it, and I'll get my two values for the partial pressure of N2O4. And so when I add this and subtract it, I'm gonna get the partial pressure of N2O4 is equal to 2.0509, 2.0509 atmospheres, or, so that's when I add it. If I subtract, then I get 1.0971 atmospheres. And so so my partial pressure of N2O4 at equilibrium is either going to be this or this. Now, if we go back to this equation here, if I take this value and I plug it in, I'll get a negative pressure of NO2, which makes no sense. So this cannot be the correct answer. So this is the one we have to go with. So that is the partial pressure of N2O4 at equilibrium. So now we have that partial pressure at equilibrium. Now we have to figure out what the partial pressure of NO2 at equilibrium, and that's where we go back to this equation. So now we can go ahead and take the 1.50 and subtract this from it. And so we get 1.0971. And when we subtract those, we get, what do we get? We get 0.4029. 0.29 atmospheres. And so this is the partial pressure of NO2 at equilibrium. Now, so let's not lose sight of what we're trying to find. We're trying to find what fraction of the N2O4 has dissociated. So far, what we've calculated is the partial pressure of both the N2O4 and the NO2 at equilibrium. We haven't found the fraction yet. So the next thing we need to do is figure out, well, how much of the NO2 or N2O4 has dissociated. Well, if we look at the equation here, we notice there's a 1:2 ratio. So for every 1 mole of N2O4 that dissociates, you're going to create twice as much NO2. So if we go backwards, right, if we know how much NO2 we have, then we can work backwards and say, okay, well, if I have this amount of NO2, then I'm gonna have, that came from half the amount of N2O4 because of that 1:2 ratio. So here, what am I getting at? So what I'm getting at here is, notice that the partial pressure of NO2 at equilibrium is this pressure right here. Well, what was the pressure of the original amount of N2O4 that this amount of NO2 came from? Well, if the mole ratio, again, we're under the same conditions, under the same temperature, same volume, right? Then we know that mole pressure are proportional to each other. So if the mole ratio is 2 to 1, then the pressure ratio is 2 to 1, which means that if I take the 0.402 atmospheres of the NO2, I can use the mole ratio as a pressure ratio to convert to the pressure of the N2O4 that originally was there, that this originally came from, right? So I know at equilibrium I have this amount of NO2. I can now use the mole ratio to figure out, well, how much N2O4 did this amount of NO2 come from? And so we can go ahead and do that. So here we have 2 atmospheres for every 2 atmospheres of NO2. We had to use up 1 atmosphere of N2O4. So 1 atmosphere of N2O4. So atmospheres of NO2 cancel out. So basically I'm dividing by 2. So this divided by 2 gives me 0. Let me double check to make sure I did this correctly. That should be, oops, I forgot 29 here. This should be 4029. And when I divide that by 2, I get 0.201, 0.20145 atmospheres of N2O4. So this here is the amount of N2O4 that originally was there in the reaction container that then was used to produce this amount of NO2, right? So to figure out how much of the N2O4 has dissociated, or to get that fractional amount, we need the total amount of pressure that was originally in the container before any reaction occurred. Well, if I know that this amount of NO2 came from this amount of N2O4 before equilibrium, and I know at equilibrium I have right now this amount of N2O4, well, then the total amount of N2O4 pressure-wise would be the addition of these two together. So when I add these two together, right, so you add 1.0971 atmospheres plus 0.20145 atmospheres, and you add those together, you get 1.298 atmospheres. Now I know I have a lot more digits than I need to have, but I'm trying to avoid rounding errors. So this would be N2O4. This would be the total amount of N2O4 that I started with from the very beginning. So I started out with this amount of N2O4 in atmospheres and 0 atmospheres of NO2, right? But in then equilibrium, I ended up with this amount at equilibrium. And then I started with this, and then I ended up with this amount of NO2. Well, I want to find the fraction of the N2O4 that has dissociated, right? So I need the fraction of the amount dissociated. Well, this is the amount dissociated. So this is the total amount that dissociated to give me this amount of NO2. This is the total amount that I started with. So to get the fractional amount, I take the amount that dissociated divided by the total that I started with in the beginning. So then I take 0.20145 atmospheres of N2O4 that dissociated and divide that by the total that I started off in the beginning. So it'd be divided by 1.29855 atmospheres of N2O4. Let me just double check. Yes. And then when I divide these two, I get 0.155. Let me double check that. Yep. So this is the fraction of N2O4 that dissociates to produce NO2 under these conditions. And so I hope this helped you understand this problem and how to solve this problem. I hope you enjoyed the video. If you did, if you learned anything from this video, then please by all means like the video, share the video, hit that like button down here somewhere. Also, subscribe to my channel. Make sure you hit that notification bell up there so that you can be notified by all the videos I put out. Make sure you click all for all those videos. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me and have a great day.